Welcome to the construction show, everyone. We are filming from WEFTEC. I'm actually here in our Vancouver studio, but we're joined by BCR Environmental, their CEO, Josh Scott, and Lance Rodeman, Vice President of Engineering and Product Management at BCR. Gentlemen, welcome to the show. Great to have you on.
Great. Thanks for having us.
We're filming from WEFTEC. How's the event so far?
So far, so good. Just getting started. We started off this morning with a breakfast for our reps, which was really awesome. A lot of energy, and seems pretty crowded so far. So this is great.
Yeah, we just went to it for the first time last year, and it was a great event for us. As BCR, have you gone over the years?
We have. We're probably 14 or so years old, and we've been displaying here for at least the past 10.
Wow. Yeah, it's a good event. Okay, gentlemen, let me just let Josh to start with you. Just sort of, I like to say, not your role, obviously, with the company, but just sort of the day-to-day with what you do with BCR, and then maybe tie that in with just an intro. And then Lance, would like to talk about your role with the company as well. So Josh, start with you.
So yeah, let me start with an intro to BCR, who BCR is. So BCR Environmental, we are an applied engineering company. We focus primarily on supplying solutions for municipal clients and industrial clients. We've got a couple of great products. We've got a large industrial dryer, and then we also have some advanced oxidation equipment. My role primarily is to build and lead a team that's delivering solutions that really answers the needs of our markets and customers. And we go to market through a series of manufacturers' representatives, and they connect us with design engineers and municipalities who have the needs to process their solids in some way or another. And so we're the folks that supply those solutions.
LinkedIn's an amazing thing. So you get to sort of look down and see someone's history on LinkedIn, and you've got an interesting look, like GE and Flowserve, and you've been with some great companies along the way. When you came into BCR, what did you sort of have a mandate? Did there sort of a vision, or was it your role to sort of bring that vision?
I came in under an interesting scenario where I was with a company that manufactured the equipment that BCR manufactures now, and so I moved into BCR, and we ended up buying the intellectual property of that company, and so BCR at that point was really focused on the advanced oxidation equipment, which is what the company was founded around. And what we saw was the prior leadership was trying to do way too much stuff. And so my vision when I came in was simplify, focus on the equipment, and try to build the team around experts who could, solve problems more than anything else.
It's a great answer. I've said it many times in the show, so I'll keep it brief. But I lost my first company, a big in part for that reason. We went from doing one thing to within like 3 years, we did like 7 things. And the more stuff we did, the less money we made. It was a good lesson to learn, though, when you're young. Okay, Lance, what is your role with the company? Let's talk about just sort of overview, but also sort of your day-to-day. What's your role?
Yeah, overview is being the engineering leader for the company. And Josh mentioned it earlier. I was one of the folks he picked out of the ether to be a leader on the engineering side. Hopefully you did a good job. Thanks. It's been a great almost 4 years here for me. And, my day-to-day is making the product the best that it can be, and then translating that value through to what really matters to the end user, which is either the customer or also the design engineer. And then supporting them through the complexity of these systems and making it as easy for them as they can possibly get.
Let's talk about our heavy industry tour brought to you by Orica Digital Solutions, leading drill and blast into a new era with next-gen Shot Plus. With market-leading design tools and predictive modeling capabilities, next-gen Shot Plus equips drill and blast professionals to effectively improve blast designs and achieve optimal outcomes. Click below to learn more about Next Gen Shop Plus. We are heading to events across North America and Australia and filming episodes on location. Email us at info@crownsman.com to be part of Crownsman's Heavy Industry Tour. Did you know cementitious binders can be responsible for up to 70% of the total GHG footprint of mine backfilling processes? Now you can replace up to 50% of the binder in your mine backfill operations with Graybond, Graymond's new low-carbon cementitious binder. This lime-based alternative binder maintains a 40 to 70% lower GHG footprint compared to typical cement and can adapt to varying mine conditions without compromising performance. Learn more about Graybond at graybond.com. Pumping systems. They're the heartbeat of manufacturing, but they can be real headaches, can't they? Vibration, pulsation, back pressure, it's a wonder anything gets done efficiently or safely. That's where Blaco comes in. Their pulsation dampeners, back pressure valves, and other solutions are designed to tame the chaos, improve efficiency, and add reliability and safety to your pumping system. Imagine less downtime, lower maintenance costs, and a whole lot less stress. That's the Blaco difference. Blaco Industries, smooth flow, smooth operation, made in the USA. Visit Blaco.com to learn more.
So when you're trying to streamline these products or bring new ones on board, is it how, I don't know how to ask this question properly, but like how complicated is it? Is it that you know what needs to happen and it's just about designing it, or is it also about finding where the errors are, finding pain points, and sort of what is that process?
I mean, my process is to get as much information from the customer as possible and then know that that information is going to be seen through their lens, and find other viewpoints to find the other points that are, basically causing issues. One of the greatest pieces of advice that I always got was look at it from the high end, but also look at it from the ground up. And part of our commitment, as far as we goes, we listen to all parties, which is not just the design engineers, the guys that, have a bunch of degrees and potentially PhDs and things like that, but also go talk to who interfaces with the equipment every day for their job. And that's really where you get to see those pain points that, obviously on paper this is going to work, but in reality, how is it truly translated through into action? That's what my process is, and that's kind of what we've, done here.
Do you find consistency when like, if there's a pain point, if you're talking to 10 different companies, will you find, is it pretty consistent? Do they generally have the same things that they're trying to sort of get past?
Absolutely. When you look at it, I'm a process engineer. So whenever I look at it from a 50,000 foot view, the process flow is all the same. Everything, you're trying to affect the same change with each process step. It's just based on regionalities, differences in climates, things of that nature. There's going to be an optimal choice for each one of those blocks at any given plant. And knowing, the ins and outs of how to apply those best is what makes a good partnership between a design engineer and a vendor.
Yeah, Josh, I'm going to bring Lance back in to go through some like very specific products that which is quite incredible. I was doing a crash course yesterday on it. But in your leadership role though, how do you then manage, because there is this inflow of information, and then ultimately there's these decisions that need to go back the other way from leadership. How do you sort of manage, because there is probably on your desk right now, there's probably 50 different directions you can go. What do you have sort of some guiding principles that say, okay, this is what we're sticking with?
Yeah, I mean, so for me, my leadership style, I believe it to be very collaborative. So I want to have all of the inputs that I can possibly have from all of the people that I trust, which is the leadership team. And, I want to make a collective decision on, directionality based on that. And if there's conflict, then, I'll be the ultimate decision maker. But for the most part, I want it to be collaborative, because then everyone has stake and buy-in in the decision that's finally made, and then it'll be much more supported.
As heavy machinery specialists for mining, SMS Equipment knows performance, like the performance they achieve together in a partnership dedicated to the success of their mining customers. At SMS Equipment, they're more than machines from trusted brands. They're the people beside you today and every day, bringing industry-leading technology and expertise to your mining operation. Because the right partnership makes everything possible. SMS Equipment, partners in your possibilities. Discover what's possible at smsequipment.com. Join us in the depths of the mining world, where global leaders and industry giants converge to shape the future of mining. From groundbreaking technologies, advanced machinery, revolutionary safety measures, to sustainable initiatives. This is the voice of mining. This is Mining Now. Showcase your company to millions worldwide. Book your episode now. Visit crownsman.com.
Yeah, well, let's jump into the actual technology because we've got a few to get to and they're quite interesting. Let's start, Lance. Let's start with the BIO-SCRU. Like I said, I was doing a crash course. I thought I understood it. The more I dug, the more I was confused. So I'm going to hand it over to you to give that bird's eye view of what it is, but then let's get into some details of the actual processes and examples of it in a process.
Sure. Yeah. The block that it fits in is it's a heat exchanger in simple terms. And the reason that we're doing heat exchange is to try and evaporate water from biosolids. Biosolids, they go through mechanical dewatering ahead of us, which gets them into the range of having 80% moisture content. And when it comes into the BIO-SCRU, the job, therefore, is to do one of two things, or both. And that is to either shrink the volume and the mass that somebody has to transport these solids to get them out responsibly, either to go to landfill or to land reuse, and also to sterilize it. And to do that, we use heat. And so the way that we use heat, when you drill down a little bit further, there's usually two ways to transfer heat from an engineering basis. One's convection and one's conduction. There's also radiation, but we're not doing that. So we choose to use conduction, and that's really cleaner here. It's called an indirect drying technique. And really for a lot of places, that means that you're not having to treat large volumes of air that you're using to dry solids. So instead, we have an intervening heat transfer medium, and that's why we called an indirect thermal dryer. And not only is it a dryer, but we also are a conveyor, which is a little bit more complicated because you have non-Newtonian fluids that you're moving, which means they don't react to stress and strain the same way as the fluids that we deal with every day, like water.
I'm going to have to clarify, what does non-Newtonian mean?
Okay, so let's think of something. Dough is non-Newtonian. So like when you're making a nice dough for a pizza or something like that, and you figure out that you have to push really hard on it to get it to move, but it seems like you have to put exponentially more energy into it to get it to move. That's non-Newtonian. So it's a way that fluids react to shear, essentially.
I like how you went from bio-waste to using dough as the example. That's
Hey, I just think what's important to me. I love a good pizza.
Yeah, I guess it is. It's getting towards lunchtime too. Okay, so
there you go.
So this design, let's go like real world application. Where is an example of where this is set up, the use case, why it fits in from a fiscal standpoint for the client, but also from the process standpoint?
From a fiscal, and that's usually the driver. There's usually two drivers, either fiscal or regulatory, but most of the time they interact pretty closely. Fiscally, transportation is really expensive, and transporting water, if you don't have to do that, is difficult in some areas. So responsibly dealing with biosolids is a big deal. There's different things in biosolids. There's beneficial nutrients, but there's also certain biosolids that come from industrial waste. They have heavy metals or persistent organic pollutants that have to be landfilled or retained. And transporting water just makes that a more expensive job. In the background, in the real world now, there are less and less places that are willing to take biosolids because of what I just mentioned with their physical properties. They're slippery. They don't deal with slope very well. So if you're an operator of a landfill, you actually don't want biosolids. So they end up charging more for them, and then they end up having to mix them with dry goods to be able to landfill them responsibly so they don't have a landfill slide or collapse. And so those costs really mount up on municipal operators in biosolids and wastewater treatment to be a big portion of the cost that they expend at a plant if they're not able to go to thermal drying. And if they are, what happens to them is it unlocks a couple things. One, the volume is way down. The volume and the mass that they transport is way down. And in our current energy market, that we have energy that's relatively cheap available to us. All things considered, compared to being able to transport that. And the other is that it also sterilizes and makes the solids very attractive for somebody that would like to use them for beneficial land reuse. And that what we're doing is we're sterilizing any bad actors, bacteria, things of that nature.
So the dried solids can be certified as a fertilizer.
Correct.
And then sold, bagged and sold. If you can go to like a big box store, and there are brand names like Milorganite is the one that everyone has heard of,
Yep.
and this is just pelletized dried biosolids.
Right.
Okay, so Okay, just paint a picture just quickly then. If let's say a municipality, I know you won't have the exact stat, but would 90% of them have a system like this in place, or is it like 10% of them? Or most municipalities still just dumping their bio waste somewhere, like in wet form?
It depends region to region. What we see are, as Lance mentioned, the two biggest drivers are how much does it cost to dispose of my biosolids, and how much does it cost to transport them, and then third is how much regulation is in place preventing municipalities from land applying. So the most common disposal methods are either you're going to land apply in a field on some kind of a grass crop or non-consumable crop, or you're going to put them in a landfill. And depending on the costs of those things is going to determine how many of these types of machines are going to be in that region.
Right.
If I look at Texas as an example, Texas is super interesting. It's got a couple of big city hubs, and those big cities will typically try to go with some kind of a drying solution because they don't want to drag the water 50, 100 miles away because it's very expensive fuel wise. But then in the surrounding areas, there are all these very, very small wastewater treatment plants, and most of those are just loading liquid sludge into a tanker truck, and it's going to be sprayed on a field or it's going to be disposed in a landfill somewhere. Just because there is so much open space in Texas, as an example.
And what goes out is regulated. So there are testings that have to happen to look at persistent pollutants and there's agronomic application rates. So there's a guideline. It's in the CFR 40, so CFR 50340. So
well, I was going to ask, so like regulations, so are you seeing an uptick in demand or even in inquiries because there's more regulation, more focus on this, even in the last few years?
Yes, there's multiple things pushing demand into thermal drying. One is less landfills that will accept solids.
Yep.
Number one. The second is increasing transportation costs and uncertainty about those transportation costs with rate of increase. That's not attractive to a ratepayer or somebody that's in a municipal situation. And then most recently, and probably very importantly, is persistent pollutants that are bioaccumulative, right? And could be very dangerous. And so a lot of states have leaped ahead of any federal regulation as the whole system is made, where the state should be acting first, and they've taken upon themselves to regulate state by state.
Right.
Which makes it kind of a complicated WEG to deal with, but drives in customers that are regionally specific because of the regulation forcing them.
Once the investment is made in a system like this, then it sort of stabilizes the cost, right? Because I was watching a video about it, and they were talking about they put in the settings and then they come back the next day and it's still just working. There's not a lot of like hands-on. It's a very robust system. So it's sort of that cost, like you're talking about transportation, that can just spike and fluctuate, usually fluctuating up. This is pretty stable, I would assume.
Yeah, the only real variable would be fuel cost, electricity cost. So we need some electricity and some natural gas in order to heat the biosolids.
Yeah, we should just. I know there's a couple more. I'm getting hung up on this one because I was watching it. It's very interesting. But let's move on, Lance, to the clean. I think it's called CleanB. Do I have that right?
Yeah. Yeah, you got it.
And I want to just walk it through it. But there's an interesting chart that you have, and I don't know if you have this in front of you, but it shows like the illustration highlights 3 different applications for the pre-treatment system. It sort of looked like 3 different inputs. But anyway, let's just walk through the technology first. Yeah,
sure. CleanB, like Josh mentioned earlier, is an advanced oxidation technology where we safely generate chlorine dioxide on site, in situ, when necessary, at exact rates for application into wastewater. And the wastewater that we're applying this to is relatively concentrated. It's essentially the waste activated solids that come off of a secondary treatment system, but they're usually in between 0.8% to 2% solids, and they need to be Yeah, so it's relatively thin slurry. You would think it's still able to move, and we sit in between that waste pump and the dewatering, and that's mechanical dewatering. And so, getting to Class B is a different level of land application suitability than Class A. It means that there's EPA has PFRP and PSRP, and PSRP is significant reduction of pathogens, and that's what Class B is listed. So this is a step to where land application is much more broad. You can use it on more things, but you're not taking it to the Class A level. And CleanB does that very efficiently, very quickly, and very, I would say, economically. And so it's literally just a plug flow reactor. Think of like a flocculator tube or a pack. We're engineering for a certain retention time. We engineer for 10 minutes. The reaction time for chlorine dioxide in water is about 7.5 minutes for full absorption and complete reaction. And we're generating that with only 7 moving parts. It's a very simple device, and it's very easy to implement inside of an existing customer system. And that gives them the power of going away from a different offering that's more of a process solution like aerobic or anaerobic digestion.
That's what I was actually going to ask you. I was watching, I think it was maybe Marengo, WWTP. Yep. Is that familiar? Yeah. So I was watching.
Yeah, City of Marengo, Illinois.
Yeah, the case study of that. And they were saying it's replacing. So I wanted to just understand what system they said, I think within like a couple of years, they're going to fully replace that system. Yeah. With yours.
They had an anaerobic digester. So that was a 2-phase digester system where, essentially what you're doing there is you're allowing microbes to eat themselves, compete until one is dominant, and then forming a place for it to die. And they consume all of that biomass and then put it into themselves, solids, die, drop out. And when they're doing that, they have cellular respiration, and they're transforming some of the mass that came in into gas. In an anaerobic digestion, that's going to be usually a methane-rich gas that you can use. But Marengo had such a small flow that it's not really, I would say, economically viable or easy to operate. And the big problem with Marengo is that they had shared unit processes. So they were using the same piece of equipment to thicken as well as dewater, which meant they had a semi-batch operation. So it was really difficult for them to operate. And some other things happen when you do anaerobic digestion that are, they're known. It's hard to deal with. And one of those is that you have solubilization of nutrients. And these are the nutrients that on your water discharge side are the ones that are under the microscope. And that's, usually nitrogen and phosphorus. And if you're using anaerobic digestion, you have to have another side stream process to deal with that. And they were having such high concentrations that they couldn't deal with it. And they had to basically make do. And they were causing their nitrogen discharge levels to creep up, which is really what Clean Water Act, just really regulates on. And so they needed some simplification in a different way to get to their Class B solids. And for them, a great solution was CleanB. And so from that, they stopped all of this semi-batching, side streaming, went directly through the CleanB process. It gets to Class B or less than, usually you're talking about hydraulic retention times of 30 to 60 days. And so now they've just shortcutted that into 10 minutes. And imagine how much easier that makes it to operate.
And it's a smaller footprint and everything like that. Absolutely. As well, right? Yeah.
Yeah.
Josh, do you have an idea in the market? Like, again, sort of going back to the other question that I asked, do you have an idea of the market of how many operations this could plug into that aren't using it, that are using another system?
Specifically around the CleanB?
Yeah.
Is that what you're asking?
Yeah. Like, is this a system that there's 1,000 people that could use, they just don't know about it, or it's just a legacy system that was put in place 50 years ago, that kind of stuff?
It's probably low hundreds of thousands locations.
Yeah.
So any wastewater treatment plant less than 20 million gallons per day influent that currently use aerobic or anaerobic digestion that have secondary treatment. It could go into any one of those, 20 MGD or smaller. And that's where the bulk of the wastewater treatment plants in the US, Canada, and Mexico are.
Yeah, if you look at Pennsylvania alone, they have over 10,000.
Oh, wow. Okay, so this is a huge potential market and a huge market that you're already in. So what is there... What is the hesitancy then? Is it knowledge? Is it just the investment? Like the video I saw, it didn't look like the working it into the system was actually an overly complicated switch.
No, so the thing about the municipal industry, it's both good and bad. It moves at the speed of an iceberg. So to get the inertia is a bit of a challenge. But once you have the ball rolling, we anticipate that the growth will be pretty great.
Yeah.
So I think it's just a matter of inertia.
And sort of investment on it. What does it take before you think they sort of gain their investment back into it? Because obviously it is an investment to do the switch, but is it like 3 years, 10 years? It
depends on their current situation. It could be less than 1 year. For instance, if they have an aerobic digester that is in need of replacement, for example, the cost could be justified immediately.
Yeah, we've had payback periods that are, day one. Yeah.
Wow.
For capital avoidance. So essentially, that's the capital avoidance usage case of CleanB. Instead of putting in $7 million of concrete and 100 horsepower worth of blowers and things of that nature, take your money instead and recoup millions and millions of dollars immediately by putting in a CleanB.
It's amazing. I just want to, I don't know if you have this in front of you, but it's the illustration. I wanted to quickly touch on it. The 3 different applications for the pre-treatment system, and it looks like it's like 3 different deliveries. Do you know what I'm referencing here?
Yeah, I think what that's trying to show is that the CleanB can completely replace some of those unit processes.
Right.
So we can go completely around the aerobic digester, completely around the anaerobic digester, and you can use it as a pre-treatment to drying with the BIO-SCRU.
Yeah.
So when you treat the solids with the chlorine dioxide, it makes the energy required to dry those solids less. So it makes the dryer more efficient.
Yeah.
And it also knocks down odor. Sorry.
I was going to say, it does the same thing with dewatering. We change the zeta potential of the particle, which means that it will remove water from itself a lot easier. So you're not climbing the hill to push that water out as much. So.
Well, it's a pretty hard thing. So basically, though, the hesitancy is just, the size and scale where it fits in. It's just basically an education piece and working with the municipalities who are typically not, like you said, glacier speed. It's sort of their calling card, if you will.
They have a responsibility to their ratepayers to get the absolute life cycle out of the equipment they've already invested in until it's the last moment, right? And Josh calls it an evangelical sale, which is absolutely true. You're sometimes, a lot of times we find our entrance to a customer is held by a design engineer, right? Because they're the ones that have been tasked by the customer to go out and find a solution. It's not the customer's job. It's not the operator's job to go figure out what technology is going to work for him. He knows what needs to be done, and he goes and hires somebody to do that. And sometimes whenever you're going to be saving that much money and time and engineering labor, you're sort of working against their best interests. So you will find special design engineers and good people, usually that are co-located within the community, or maybe they're a ratepayer themselves, and they'll be like, well, this is a much more efficient way to do this.
Right.
And we've made a couple of inroads, and that's why we have repeat installations by certain engineers.
Right.
Yeah.
Okay, so because that's what's going to my next section is wanting to go that go-to market strategy. So it's sort of the engineers that are hired by the municipalities. That's sort of who you need to get to open those doors.
And a lot of times it's because of who we're dealing with, small to medium-sized municipalities that don't have, those engineers on staff all the time that are going to be doing that. There are larger or more, I would say, better funded municipalities that do have those personnel on board, and we've been approached by them directly, which makes it, a little bit different of a sale or a go-to-market strategy.
But this is an interesting thing. So, Josh, if you want to speak on this, because you could drive through. I'm from an area where there's a bunch of small towns, and there it might be 15 years from now before they're even going to start the conversation. They've got a system in place. They put it in 10, 15, or 30 years ago, whatever it was. You can't really just go knock on their door because they're just simply not ready, even if they clearly need it. There's not even an engineer on staff that can have the conversation. It's to understand what it sounds like.
No, typically there's got to be some type of a problem that we're reacting to that gets some kind of activity going. There's an odor concern. When you start having homes encroaching on a wastewater treatment plant, a lot of the homeowners don't really like the odors, and so that's one of the things that the CleanB can do is eliminate odors. There's got to be some kind of prompt in order to get either our rep or an engineer to go to that facility in order to start the problem-solving solution, right? They've got to start with some kind of a problem.
Right. And when you actually once the project gets started, are you doing the installation? Do you partner up with engineering firms? What is sort of the actual onboarding process of getting these units on site?
Yeah, so there's two different ways that we can deliver this system, either in a 40-foot shipping container type of a scenario, or we can deliver it into existing or new infrastructure. So if we're delivering it in the shipping container type of a way, it's pretty easy for us to oversee. We'll hire a general contractor, they'll drop it into place, and we'll oversee the hookup, and then we will conduct a performance test. Similar situation if it's going inside of a building. We'll hire a general contractor, we'll oversee the installation, and then we'll go through a startup phase.
That is exactly true. Sometimes they end up hiring their own contractors through an engineering firm, where the engineering firm, because a lot of times this is not a singular project, it's part of a suite of upgrades, and they're doing a lot of simultaneous work on site. And so they end up doing where the engineer, the design consultant that they've hired, they're the ones that design the plans, make sure everything's going to fit, and they're the ones that supervise the contractors. And
right. So it's even like a it's a construction site. So you end up with your head of contracting, and then you have subcontractors and all that sort of thing as well.
Yeah. And BIO-SCRU is much more complicated and difficult to deal with than CleanB, but CleanB's pre-modularization makes it very, very simple to put on site.
But the BIO-SCRU is more of an infrastructure. There's infrastructure around that as well, right?
Yeah. There's many supportive unit processes that support our dryer that are necessary to be installed, and utilities as well.
Okay, Josh, just before I let both of you go, what is the outlook going over the next couple of years? I don't like to do 7-8 years out. That's things can change, but what is sort of the focus right now over the next couple?
Yeah, so I'd say we've got 3 areas that we're really focusing on. Lance mentioned these materials of concern, and there's a lot of discussion right now around PFAS or microplastics, and that effect on the human body and where it is, and it's everywhere. And so we're partnered with a couple of companies to provide a PFAS destruction solution. We think that is going to be a very large growth area, and drying is a necessity in order to get to the phase where you can destroy the PFAS. The other area that we really didn't touch on too much when we were describing the BIO-SCRU is all of its industrial applications. And there are just hundreds of applications, given that this is an indirect heat exchanger. It can heat and it can cool, and it can be in the middle of a process. For example, we've dried cocoa nibs and Swisher sweet tobacco and gypsum for a wallboard manufacturer, and we've taken molybdenum out of a copper mine stream. There are just hundreds of different things that this machine can do. And so we're going to selectively pick several areas and focus on kind of expanding our reach into some of those areas. And then the third thing is that we're going to focus on more services. So not only do we sell service agreements with all of our sales, where we can go do predictive and preventive maintenance, but we're also going to be offering our drying as a service to the marketplace in the near future as well.
So what do you mean by a service? Like as in like a temporary thing that needs?
Yeah, so we would do like a long-term leasing arrangement where either the client or BCR is operating the equipment, But at the end of the day, BCR owns the equipment. We take all the responsibility for the maintenance and upkeep and uptime. And we're charging on a per dry ton type of a arrangement.
Part of what you mentioned, the impediments into the market like this, because it's such a complicated project, there's those complications no matter what, but part of the complication is funding. Dealing with access to public money and doing that responsibly through, capital budgeting has its own set of, ladders that you have to climb in any municipality or any area. And being able to offer something that's differentiated to that will be able to speed up adoption in the marketplace, which is better not only for us, but better for the people.
Well, especially for a small community, if you're putting something like this in, everybody's going to know about it. Everybody's going to have a voice, and just getting that funding together can be. I was going to ask just quickly with the BIO-SCRU, does in these different applications, like you're talking from like coffee to mining, is the design of the machine the same? Because or does it actually, for mining, is it a heavier duty internally, or is it pretty much the same unit?
There are some nuanced changes to it, but it's largely the same design. But to your point, if you've got an extremely abrasive material, we can armor plate the augers, for example, for durability. But largely, it's the same design.
Oh, from a detail perspective, a lot changes. But in reality, looking at it from
I saw the engineer look in his eye. I was like, the executive answer and then the detailed answer.
Well, an engineer is going to say, well, actually, no. But the heart of the technology is always there. Like finding that an indirect hollow flight screwdriver or screw, or auger, what Josh called it, that is always the heart of the technology. And then wrapping around that, how to be the most efficient or the best in the longest life cycle, changes from whatever you're doing. And then also there's so many other things. That's just whenever you focus on the solids, you also have to focus on what it is you're removing. So a lot of times it's water. Sometimes it's not water. It's diesel range organics. Sometimes it's fat, stuff like that. Yeah. Yes. Yeah. And you're dealing with all that condensation and the stuff that you've basically expended all that energy on getting out of the solid stream. Now you have to find a way to recapture it, or deal with it. So
when you're talking to a client, do they have a pretty good insight on, are they able to provide a lot of information, or do you really need to gather and sort of figure out that design based on what they have? If that makes sense.
Usually an industrial customer will have engineers on that will be able to give you exactly what you need. And from that's when each application is slightly different. You have to have a lot of information. What's nice about and how we've been able to make a repeatable product with BIO-SCRU is that even though everybody will say that their solids are different, they are technically, but they're within a guideline or a laneway that we can actually process. And, so whenever we go to market, we can give people within plus or minus 5% accurate budget quotes immediately just by knowing a few things from them. And what's great also is that from the permitting process, you're able to look those up. You really don't even need to ask them a lot of those questions. However, when you're getting into the detailed design phase where they want to know everything, you have to know a lot more. We have really great tools. Josh has been part of the group that's been able to invest in for us having on-site demo units that we can roll up to a customer's site. And what that gives from a marketing and sales perspective is the guys can literally come out there that are going to potentially operate this equipment and see it and feel it and touch it and ask us about maintenance. And from my side, I can get a complete heat and mass balance, and I can look at the ins and outs of all that data that it's generated. And usually we give clients a 50 to 60 page report with all that detail from them doing that demo. And that usually is a great stepping stone to making a sale and making people feel good about it.
Yeah. Josh, last question to you. I noticed one of your visions is more than 1,000 ongoing customer relationships, which is a lot for what you're doing. Is that part of that vision? Is that the leasing the equipment strategy, and is that part of that?
It is, but I think the more important part of that statement is the customer relationship. So the reason we wrote that vision that way was to really emphasize that we want to be, aligned with the customer 100% and maintain those relationships. So it's not just we're going to sell you some equipment and then we're out of here. We're in it for the long haul, and we're in it with you. And that's the message that wanted to come out in that vision.
And I noticed in some of your videos with your case studies, you had clients talking about that support. And people will not come on video and say that for you unless it's true. So it's quite a good sort of recommendation from your for your company from your clients. It's can be quite difficult to get.
I was so excited. The last video that we did not have a single BCR employee on it.
Yeah.
It was 100% clients. It's so cool.
Yeah, no, it's an amazing accomplishment to be able to do that and have people come on. Gentlemen, I know you got a busy show and we were running a little bit late, so I will let you get back to the event. I mean, there's so much we could cover. We could look at more case studies and more applications, like we kind of touched on. But I know we're going to be out of time for today. So thank you very much, and I hope we do it again.
You.
All right.
Thanks, Jared.
Thank you.
And thank you, everybody, for watching. Of course, we will have links to BCR in the description, but we'll also have links to the products like CleanB and the BIO-SCRU. So just go to the link below and you will be able to click directly on, or the description below, and you'll be able to go into each of those sub pages. We'll also have links. They've got some great case study videos that you can actually watch in their full form. So thank you, everybody, for watching. Please make sure to subscribe and follow us as well. And we'll see you on the next episode of The Construction Show.